Okay, this is the second part of the lecture for chapters 14 and 15. And this part's going to start off with just looking at some weathering. Just to note that there are three different types of weathering, so if you had to know an example of these, you could say biological weathering. Let me switch back over here to my felt-tipped pen. To kind of point out, biological weathering would be something that is coming from something alive. Chemical weathering would be, whether it's usually an acid, maybe a gas, so acid deposition, rain, fog, whatever. And then physical weathering would be some physical process, so winds, water, frost, freeze, that type of relationship. And what it does is it breaks down large material, rocks, into smaller materials, sands and such. So classifications. Non-renewable resources. So looking at these, the U.S. Geological Survey classifies resources in regards to identified things that we know, we've seen them, we know where they are, we have a general idea of how much we have there. Undiscovered, as the name implied, we do not know. But we assume that based on what we do know that they may exist someplace else, but it's kind of a guess. Reserves, again, these are identified materials, and we know that we can take them out of the ground, and we're just waiting, biding our time. We're not taking them all at once, but we can take them out for a profit today, and of course that can change in the future. So you have others, which is just kind of a catch-all, but what it also kind of gets to are materials that we just don't really have a use for yet. So maybe in the future they're not classified as reserves, but it's based on technology. We may find a really valuable resource or use for them in the future. So, and this kind of, it's a decent graphic. Basically what it shows is, we have an economical usage for some of these materials, whether it's a hydrocarbon material or it's an iron ore, but something that we use for profit. And then we have other materials that we don't really have a usage for. They're low energy content, or they're in such high abundance that we just don't use them for anything. But then the other one is this non or undiscovered materials that we just kind of guess that maybe they're out there. We just haven't found them yet. So it's just kind of open. All right, so I like this one here. Kind of going back and going over something we discussed earlier. First of all is that the Earth's crust is primarily made out of oxygen. Almost half of the material is made out of oxygen, and everything that you find is typically some type of an oxide. So if it's iron or magnesium, it's typically iron oxide, magnesium oxide, calcium oxide, or some mineral that has oxygen within it. But as far as the crust goes, and we mentioned this before, iron oxides, they're more dense than other type of metal oxides that we typically find, and they're going to be at a lower level in the Earth's crust, many times oceanic crust. And continental crust usually is made more of silicon oxides, and they are going to be lighter and higher up. So most of the continents are based on silicon oxides. So sand, as an example, is silicon dioxide, and again, most of these other ones we're going to find is oxides too, but not completely. Okay. Rock cycle, and you learned all these before, so we'll breeze through these. Igneous comes from magma, and you can have two different types. So just something to hold on to is you have intrusive, which means the rock formed within the surface. Extrusive means it was blown out and it cooled on the exterior. Sedimentary could form from any type of rock, but it usually forms in layers and it's compressed over a long period of time. Metamorphic, again, it could be either of the other two, in which that it has been pressed under pressure and temperature and it has changed form from what it was previous. And this just kind of goes to that same example. So if you want to take a look at some examples of each of these, you can look at those. And moving along. This last little slide here is just to kind of show That's, how do we use our resources now, and is there potentially a better way that we could, and just kind of, giving that thought in regards to recycling or reducing our usage of these things. So one of the things I was mentioning in class is the true cost of a material. So we go through all of this work here, and yes, there is a price of a car, and a lot of it is factored in there. But if you think about, the price of a car, let's say $30,000, yeah, a lot of these costs go in as far as, getting the metal ore. Of course, somebody had to pay for it. But once we get to this level here, is the cost. Sometimes, we don't always think of that, and there's, it can get really, really complicated when you start talking about roads and repairs and the oil industry and all the regulations that go along with those things. But I was just kind of limiting it to, okay, your car is done. I'm not sure what happened here, but the car is no longer in use. There's a lot of cost that goes into redistributing those materials back into the chain. You don't pay for those, but they are, picked up somewhere along the way, and they're not really always represented in this true cost of, an example, $30,000. Interesting little graphic here we had in the book, just kind of going over the cost. Actually, it's from another book. The amount of reserves that we have in comparison to the rest of the world. So if you just look at iron, supposedly we have about 40 years of iron at our current usage. And if you look at the world, there's about 120 years. So somewhere along the line, we have to start doing a little better job of recycling. I found this one very interesting. Comparatively, we have very little, if any, profitable amounts of these metals left that we would go after. So we get them mostly from other places. And you can see, again, looking at the amount that's out there, eventually we're going to have to start recycling these materials, or exclusively recycling these materials, because we may have discovered them all. Alright, switching gears over to mining, and just looking at a couple different examples that you would probably need to be aware of for an exam. So open pit mining, this is a nice little example of that. So you find a location, you just follow the ore wherever it takes you. And in this case, the ore deposits were in this, appears to be a mountainous area. And eventually you get to, an open area here where you could have a lot of runoff or heavy metals, whatever potential pollutants may be gathering along the way. So the main idea with all these types of minings is you have this mature parent material that's been sitting there for millions of years, and we come along and disturb it, and now you've opened up what was beneath this surface area, and now it's all exposed. So you could have a lot of heavy metals or whatever else might be present now open, and it's eroding away, and it could be finding its way into waterways and, of course, drinking water. Strip mining, the exact same idea here is you have parent material resting, and this is depicting all the spoils or the till that was taken out of a mine, and these are all open to the environment, and it makes it possible for contaminants to enter into the waterways or wherever else it may land. Same idea. Contour strip mining. This is probably the one that's most familiar to people in regards to coal. They do quite a bit of this in Ohio and Pennsylvania and West Virginia. You find some coal and you just follow it. But notice, as far as this type of mining, that we're not too deep into the ground. So we may have started at some hillside that was actually at surface, some distance in the back, and then you just keep following it wherever the terrain goes. So this vein, or seam as they're calling it, may eventually just run out, or it may go deeper and deeper and deeper, and then this may get to a depth that we can no longer just do contour strip mining. We may have to think of something else, some subsurface mining. And the one thing they do mention here, as far as a vocab word, is a high wall, which just means you keep following the terrain, and as this hill gets higher and higher and higher, you end up with some type of feature that you didn't originally have. And okay, the question becomes, what do you do with it? Many times it says you may just leave it. Mountaintop removal, they do this a lot, of course, like in areas like the Appalachians, where we have a lot of coal, and we also have some mountains. So we have a really difficult time getting appreciation for this area, the vastness of what this mine is. It's a pretty big area, and I'm curious, I still can't tell looking at it, how much material was removed from this mine. Looks fairly significant, but I really don't appreciate how large of an area it is. But of course, same principle all the way around, exposed materials, contaminants. Impacts, just kind of going over what we've already mentioned. One of the things to look at is the idea of smelting. So just think of that word. It's how they remove metals, or many times how they remove metals from the ore. The ore is the rock that the metals are within, and it may be just available. So for example, copper or iron or gold even may just be sitting right in the rock, or maybe in combination, and they have to chemically treat it in such a way that they can get the solid or the elemental metal out of the rock. So they'll use things like acids, or it could be a cyanide based compound, to remove that material, and neither one of these are necessarily good for the environment or you. Subsurface mining, we watched a little video on that, and it's interesting from the standpoint of how they can go that far into a mountain. So as a video we watched showed, they go 20 minutes on a little trolley ride into the mountain, and it's very, very dangerous work. So if you were thinking about what's the most difficult or dangerous part of this mining, it would be subsurface mining, because they're in a confined space. It's not a place people are supposed to be living. They spend quite a bit of time down here, and there's an assortment of hazards as far as the air quality, the contaminants that they're breathing in, falling debris, explosions, cave-ins, a number of different things. All right, we've gone about 12 minutes in, so I'm going to take a break here, and we'll come back and do number 3.